Welcome to the Software Assurance Marketplace Virtual Town Meeting. Our topic today is Shaping Your Approach, the Executive's Role in Software Assurance. I'm Marcy McCarthy, the CEO and President of T.E.N, and I'll be your moderator today. We're excited to bring you this live event and expert presentations on strategies to drive software assurance within organizations. It is my pleasure to welcome our presenters. Our first presenter is going to be Kevin Green, who is the Program Manager for the Department of Homeland Security, Science and Technology Directorate for the Cybersecurity Division. In his welcoming remarks, the Software Assurance Marketplace, channeling the mission of DHS, Kevin will share with us how they're tackling the problem. Our second presenter today is going to be Miran Livni, who is the Director and Chief Technology Officer of S.W.A.M.P for the Mortgage Institute for Research. Miran will discuss ways to bring the Software Assurance Marketplace into your software assurance program. And our third presenter today is going to be Jerry Davis. Jerry is the Chief Information Officer for NASA Ames Research Center. And Jerry is going to share his executive insights in his presentation, Software Assurance, because I'm tired of fixing broken toys. After the presentations, our experts will continue the conversation via a live Q&A. We will also be recording today's event to provide an on-demand recording for viewing by you and your fellow colleagues at a future time. And I want to make mention that you are also able to earn a CPE for today's event. And if you would like us to submit that CPE on your behalf, please email your certification number to Deb Jones at djones@ten-inc.com, and that's Deb Jones, and her email address again is djones@ten-inc.com. Now let's begin with our first speaker. Please welcome Kevin Green, who is the Program Manager for the Department of Homeland Security, Science and Technology Directorate for the Cybersecurity Division. Kevin, take it away.
Thank you, and I want to say welcome to our virtual town hall meeting. I think this is an excellent opportunity for DHS to share with the community the work we're doing to help improve software security. As many of you may know, especially at the executive level, software development in many organizations has become a huge undertaking. It has become increasingly challenging to integrate and augment software assurance activities within the software development process. I have a couple points I would like to share with you that will help set the context to further the discussion regarding the S.W.A.M.P. My discussion points are here. We'll talk about channeling the mission of DHS. We'll talk about tackling the problem, advancements and breakthroughs through the software assurance marketplace, and the challenge remains. Next slide. The S.W.A.M.P. channels the mission of DHS in the sense that we're developing tools, techniques, and capabilities to help defend and secure our current systems to better protect our critical infrastructure against attacks from our adversaries. The S.W.A.M.P. provides the capability to help us protect our software systems against these type of attacks. Through the S.W.A.M.P., we will have a mechanism where we can leverage the S.W.A.M.P. as a transition hub for key technology and innovation developed through my software quality assurance program that I have within S&T. And through that program, my job is to develop techniques, methods, and services to help advance the state-of-the-art in terms of how we analyze software, the tools and the methods used to analyze software. Also, DHS S&T will provide leadership, bringing the research community together, bringing other communities together to work on this problem. A lot of what I do, I fund research in software assurance, and we bring communities together to try to work on these hard issues. So we provide leadership in this area, understanding the requirements of the community, whether it's Homeland Security enterprise, private industry. We get out, we talk, we want to understand what the issues are, develop those requirements, and put research dollars to help solve this hard issue. Next slide. So the challenge is growing. So software is everywhere. Software is ubiquitous, right? Software is in drones, is in cars, medical devices, It's even in our appliances. I mean, a recent report came out the other day where refrigerators were being hacked. So software is in every form of our life. It's in the critical infrastructure. It affects our personal lives and mobile devices and so forth and so on. Arguably, software is more complex. Software system code bases are larger. Software has truly evolved. And the fact that software has evolved, the tools to analyze software has not kept pace with the evolution of software. As a result, tools don't perform that well, and they are not adopted early in the software development lifecycle. And because tools are not adopted early in the software lifecycle, the cost of software failures continue to rise. A recent study done by the University of Cambridge suggests that software failures cost the global economy somewhere around the neighborhood of $312 billion. That's $1 billion per year. Next slide. So we want to talk about driving innovation and breakthroughs. Just like any laboratory, a scientist uses the laboratory to find breakthroughs and advancements in new science. We want to leverage the S.W.A.M.P in the same way. We want to use the S.W.A.M.P to find breakthroughs and advancements in software assurance activities so we can have improvements and an innovation to help us deal with this issue regarding software. So the S.W.A.M.P is going to help shape and form new paradigms as it relates to software development activities, specifically in the area of continuous assurance, where we can apply the process and the principle of frequent testing of software throughout the software development lifecycle, as well as continuous integration principles. We want to be able to create synergistic capabilities to support an array of software needs. So that goes from binary analysis, static analysis, dynamic analysis, as well as solutions to help deal with the software supply chain, as Marone Livni, who would be the next speaker, will go do a deep dive into. We want to be able to use the S.W.A.M.P and leverage the S.W.A.M.P to improve tool coverage. How can we harness the strength of these tools in a way where we provide context across the various tools, and that context helps build better situational awareness regarding our weaknesses and vulnerabilities in our software. But more importantly, how can we identify and improve the accuracy of results? No one tool is created the same. Each tool has strengths, but leverage the S.W.A.M.P in a way where we can harness the power and the strength of each tool. Lastly, we want to be able to create a learning environment to help improve software coding practices and to reinforce the good coding practices that are being taught at the universities, at the high school level. Leverage the S.W.A.M.P in a way where we can reinforce those good behaviors, those good principles. Next slide, please. So the challenges remain. I know you all heard this before, right? We want to be able to do a couple things. Through the mechanism by applying the continuous assurance principle, we want to be able to move software assurance activities early in the software development lifecycle, and we believe we can accomplish that with the S.W.A.M.P. Create better collaboration and provide technical exchange where researchers and developers and software developers, tool developers, leverage the S.W.A.M.P to find breakthroughs and advancements in new software assurance techniques and activities. We want to be able to put the A back in assurance and the T back in trusted as it relates to software. Having assurances that software has been vetted properly, but not only vetted properly, but have a level to rate and measure the overall risk associated with software, and also be able to expedite some of the activities as it relates to compliance, such as certification and accreditation. We want to be able to create better performing tools. Ultimately, the tools don't perform very well. NSA did a study, and the study revealed that one tool can only find somewhere in the range of 14 to 17% of weaknesses and vulnerabilities in software. We want to create better, sound, and precise tools that can scale with the evolving pace of software. Next slide. This is my portion of the presentation. I have my contact information here, Kevin Green. You can reach me by email, LinkedIn, or Twitter. Please contact me. I have a lot of interesting things that are going on in my software assurance program, and it's always good to hear from executives to better understand what the issues are and leverage those requirements to build better tools and innovation to deal with the software issue. The next presenter will be Marone Livni from the Mortgage Institute for Research. Ron, take it away.
Thank you, Kevin, for your introduction. And good afternoon for some of you, which I believe are under snow. And good morning to those of you who are enjoying the sunshine on the West Coast. So I will introduce to you the SWAMP and hopefully in a way that will make it clear how you can leverage the capabilities of the SWAMP in the software assurance program of your organization. Next slide, please. So what I'll try to do in the 15 minutes that I have is to quickly go through these 5 main points, introduce the SWAMP, introduce the vision that is driving the construction of the SWAMP. You heard the motivation from Kevin, and I think you will hear later from Jerry also another aspect of the motivation, but I'll try to articulate what we are trying to do in terms of a vision. Stress the power of sharing. As you all know, that sharing is caring, so we believe in it. We will address briefly the issue of privacy and confidentiality and give you a quick pointer to how to get started. Next, please. So building the SWAMP that started a little bit over a year ago is done by 4 institutions, which are research institutions. And I think it is important that to understand that SWAMP is built by a group of researchers where we feel that we have very strong credentials in what we are doing. The Mortgage Institute for Research is the lead, and then we have Indiana University with Von Welch, who is the Chief Security Officer of the SWAMP, and the University of Illinois Urbana-Champaign with Jim Basney, who is responsible for all the elements of identity management within the SWAMP, and then the University of Wisconsin-Madison, where Bart Miller, that will be actually leading a similar town hall meeting tomorrow, is acting as the chief scientist and is focusing on all the tool aspect of the SWAMP. Next, please. So what we are building is both, we believe, powerful and flexible. And we have to remember that what we are doing is providing the facility. As Kevin pointed out, we are providing a marketplace, a place where things can happen. And we believe that the key 3 components in such a marketplace is a repository of technology, of software assurance technologies, a repository of software packages, and a strong, powerful, continuous assurance engine. As you heard earlier, one of the paradigms that we are introducing through the SWAMP is the concept of continuous assurance. And I think you will hear me saying it several times today, is that we believe in the Chicago model of voting. Do it early and do it often. So the idea of continuous assurance is to make it easy to do it early and to do software assurance often. So when it comes to the tools, we are dealing with assessment tools, which is sort of the foundation. We are dealing with viewing tools, which is the way that we deliver the results to the end user. As you heard earlier, we believe in the power of bringing results from different tools into an integrated view. So there is the question of how do we do the coupling and the integration. And then we are looking into tools that translate abstract notion like CWEs into actual risk numbers that can help decision makers. When it comes to software packages, we create a repository for common open source packages and also reference test suites. We just recently added all the Juliet test suite as separate packages based on CWEs into the S.W.A.M.P. And when it comes to continuous assurance, we need two things. We need the power, the horsepower to do it. And we are today sort of spec'd at, I believe, 275 million lines per day of assessment. But we also believe that we need the automation to help build and run continuously assessment workflows. Now, when I talk about the repositories, what I listed here are both the tool and the packages that we bring into the S.W.A.M.P. and make them available to everyone. But these repositories can also host, as I will discuss later, your tools and your packages, and these will obviously remain private as long as you want them to remain private. Next, please. Here's a small example of what we have recently done in collaboration with Sonotype to demonstrate what we mean by continuous assurance. So they have in the central repository 60,000 Java packages. And we have been working on putting together an end-to-end pipeline that can apply the find bug assessment tool to all these 60,000 Java packages, or even the 500,000 version that they have on them, continuously, in order to augment the information that they have in the repository with a find bug report, and then potentially also with risk assessment numbers. We ran so far one trial of 11,000 packages, and we can do it. We are still working on all the plumbing to be in place and to run in a fully automated way. Next, please. So as I pointed out earlier, what we do, and since we are academicians, all of us, we have to work within a vision that will drive what we are doing. And you can see at the bottom a URL of our vision document. And we want to stress that we want to work with all members of the software assurance ecosystem, whether you're a tool developer, software developer, a facility manager who is concerned about supply chain, and researcher and educators. And we believe that by bringing all of them together in a single marketplace, we will accomplish what Kevin laid out earlier as the direction that DHS, Science and Technologies, is moving the ecosystem of software assurance. And in order to accomplish all this, we need a continuous assurance facility that will improve the tools and will expand the adoption of the tools. So we want to move everything together, better tools, more integrated tools, and easier adoptions. And while, as I pointed out earlier, protecting your privacy and the confidentiality of your data, the S.W.A.M.P. will identify new defect as you commit changes, the continuous concept, will identify new defects in modules that you are using. This is supply chain. Profile the ability of your tool as you make changes. This is for the tool developers. And also will make your tool visible and accessible to the entire community through the capabilities of the S.W.A.M.P. Next slide, please. So in order to do this, we need a framework, and we have been working on it, articulating it, and and implementing it. And once again, you have a URL for a white paper that Bart and myself put together about what would be involved in such a framework. And the key is that we need to be able to bring in new tools easily and efficiently, and then, as Kevin pointed out earlier, be able to integrate them into a more powerful and rich set of results. And we need also a framework where new software packages can be added. And that's the reason why we look at it as open. Not open because everyone can access and do what they want, but open that we can hook new tools into the framework or bring in more packages into testing and evaluation easily. And we are committed to develop the tools that are needed to create this hooking. And that is the third one is along these lines in terms of the integration and the interpretation of output for many tools. There are a lot of opportunities here to make it more powerful and easier for your organization to bring to bear more than one tool to your software assurance. And we want the framework to be also open with access to software product and results at all levels. So we need an open source community to play a role here, because that's what it will take, we believe, in order to get to where we need to be. And also to collect the analytics to understand how this whole software assurance process works. Next slide, please. So we know that sharing is powerful, but we also know that the foundation of sharing is protection of privacy and controlled release of information. So we are going to maximize the impact of sharing through tight protection of privacy. And therefore, each user of the S.W.A.M.P will maintain full control over access to artifacts and information that they own. But at the same time, when and if information can be shared, we will support this kind of sharing across different groups or to the entire community. And in order to do all this, we are committed to do on our end what is needed to establish a strong trust between you, our users, and us as the organization that delivers the vision. Next, please. The S.W.A.M.P is an evolving project, and we are going to open our doors for public access. We are now in the final stages of beta in 2 weeks, in the first Monday of February. And the focus is going to be static code assessment. But that's just the beginning of the story. And here you see a timeline of the feature that we are going to add, moving to mobile, more dynamic testing, provenance, and exposing API. These are the major technologies that we are going to include. And below, you see the additional technologies that will come into our repositories and into our infrastructure. And everything that we do is and will be influenced by the feedback that we get from the community. It's not that we have an agenda in delivering these things. Our goal is to make sure that what we do is in line with what you as members of the community need and want. Next slide, please. So we want you to get involved. And once we open the gate, we can even do it in the next 2 weeks while we are in beta if you contact us. But after that, simply come for a test drive. Come, create your project. You can use software that we have, packages that we have there. We have tools. You are interested in bringing up a tool. You are even interested in bringing a result in order to use the viewers that we are running like CodeDX. we can facilitate that as well. So if you want to integrate your result from your tool with result that you get from another tool, we are positioned to support that. Come and talk to us about your need, your aspiration, your challenges, because we may be able to guide you, and you may be able to guide us in what we should do. And tell us about what you are doing in your organization, and that can help, as I said earlier, both sides to move forward. And come and join us in our community building activities. Next slide, please. So here's the contact information with the logos of the 4 research institutions that are involved. Pat Meyer is the product manager, and you have his email and phone number, and you have also a way to reach me. So we are going to be open for business on February 3rd, and we expect all the, how many do we have here attending now? 93 attendants, all of you to sign in on Monday. Thank you. And now I'll head it over to Jerry, who will give you his perspective for software assurance and how to play with these broken toys.
All right, thank you everybody. Definitely appreciate this opportunity. Again, this is Jerry Davis. I'm the CEO at NASA Ames Research Center here in Northern California. A couple of things I wanted to do before we get started. I wanted to apologize for the glitch that we had with Kevin when he first tried to kick off. I actually was talking to Kevin virtually in the green room, and I was complaining about my rider. I distinctly said I didn't want any green M&Ms inside my bowl. I wanted my water at 65 degrees, and it was not at 65 degrees. And there were wire hangers in my closet. So I just want to apologize for keeping Kevin's attention off to the side. I also like to apologize to you folks out there on the East Coast. I know it's very cold and snowy out there. It's one thing I don't miss. But I thought what I'd like to be able to do today is bring a little bit of Northern California sunshine. It's going to be about 70 degrees here today. So I hope you can enjoy that. I can impart a little bit about that sunshine on you. One of the things I also wanted to bring up front, just a little bit about, I joke about Kevin, but I've known Kevin Green for probably about 12 or 13 years now. Interesting enough, I had hired Kevin when I was a consultant with DC government back in 2002 or something like that. And I brought Kevin in as a firewall engineer, and we were setting up secure enclaves all across Washington, D.C., and building their first citywide IT security program, and I was the director of WAN security architecture, and brought Kevin on board. He was a real sharp and skillful guy, and I could never understand why he was in the role that he was in, setting the firewalls. And I knew that this guy had some bigger things in his life going down the road. And eventually, we left and we went our separate ways and went on to other jobs. And eventually we met back up again a few years ago. And when Kevin asked me to do this, and I found out what he was doing with DHS, it didn't surprise me. Kevin has always been on the right track when it comes to these large, what I think are game-changing ideas and strategies about how we look at security and the work that we do. When you look at my title slide, software assurance, because I'm tired of fixing broken toys, it's basically, that's how I feel. When you buy a piece of software, it is always broken right out of the box. And so what happens is you end up having to patch these things and setting up whole infrastructures just to deal with broken software. When I was asked to do this, you always kind of labor about what exactly it is that you actually want to talk about, and how are you going to package this up and put together. You have an opportunity, you're standing on a world stage and everybody's looking at you or listening to you, and you want to make a point, a resounding point. And right off the bat, I like to say that the point I want to make is that, let's get your pencils out, is that software generally sucks. right? So when we purchase software, it's usually not in the best condition. It may be very, very functional for the purpose that it serves, but from a security perspective, it's usually very, very incompetent and not a very good product that we have. This forum, this initiative that that Kevin has put together, and along with Dr. Livney, is a great step in the right direction. And I'm a big believer in it, and it's one of the reasons why I said yes, I'd like to do this. And what I want to do is give you a little bit of perspective of my thoughts around software assurance and some of the things that I've dealt with. So this initiative is an excellent opportunity to make improvements to the security life cycle, and I definitely believe that it begins with software assurance. Some of the discussion points that we're going to go through, we're going to talk a little bit about the ubiquitous presence of software. Kevin mentioned some of that. Some of the appetite that's out there for assured software. Assured software is what I call smartware. We'll talk a little bit about some of the attributes of good software. And then some little bit of numbers. Everybody likes statistics and some real life examples I've thrown in there. We'll go on and hit on some of the benefits of software. And then I think my perspective again about the path forward. So if we can transition to the next slide, please. Today we're talking about, Kevin mentioned earlier about the ubiquitous presence of software. It's absolutely everywhere and in everything you do. And it literally is the driving force behind everything that we do. Right now, as you look at these slides, that's all happening. There's millions and millions of lines of code all rendered to you through software. You think about transportation, whether you're inside of a car, whether you're inside of an airplane, whether you're on a train, all of that is all run by software. And when you look at things like powers, utilities, water, natural gas, critical infrastructure, banking, finance, point-of-sale systems, that is fresh in our minds as we look at places like Target, as we look at Neiman Marcus and these major data breaches that have taken place. It's all run by software. Software is kind of the end-all and be-all to whether or not we have a good experience or bad experience in our day-to-day activities. Manufacturing as well. When you go into a hospital and you had any kind of procedure done, in my experience in working in security and on the side of the industry of healthcare, when you go and you look at a big gamma knife, health IT, that stuff, that's all run by software. And you know what? Those things do get infected. They do have problems because of issues with software and not putting out good, secure software. So we put a lot of our faith in what I call unassured and incompetent software. If you think about using the software that's running your car, I would ask yourself, would you let a 7-year-old drive you around on the highway? Would you let a 7-year-old pilot an aircraft? Would you let a 7-year-old balance your checkbook? I don't even like to balance my own checkbook. But we put a lot of faith in software that's untried and untested to let it to run our lives, and there's often, a lot of times, there's dire consequences to that. There's a lot of ramifications when things are managed by less than competent software. All of these things here together, you're hearing the new buzzword that's out there in the last couple of days. We talk about things like the Internet of Everything, right? So that new buzzword is basically saying that everything is connected together. We're talking in the next couple of years, just in the Internet, the explosion of devices on the Internet that are interconnected, that, from refrigerators to crock pots to irons and things like that, all being connected across the Internet. That's just going to grow and grow and grow. Software is the underlying mechanism for that, and whether you're going to have a good experience with it or bad experience is dependent upon the quality of the software and the security mechanisms that you have in that software to make sure that you have a good, a very, very good experience. We can go to the next slide, please. So what is the appetite for assured software? When I look at it, I'm not a software developer. I'm not a coder by any stretch of the imagination, but I'm a consumer, and I'm a buyer both as a private citizen and as a public servant of software. One thing I do understand about software is risk. And there's one thing I do understand very well in the security profession is risk. When you're buying software, when you're acquiring software, when you're downloading it onto mobile devices, this free stuff that's out there, or whether you pay for it or not, there's an inherent risk that's there with that software. And the manufacturers of that software, or the developers of that software, from a risk perspective, one of the things that they're doing when that software is untried and it's untested and it's not validated as secure, is they're transferring that risk to you as a consumer and the user of that software. We've been living with nearly 60 years of poorly developed and incompetent software. We spend hundreds of millions of dollars annually on post-software compromises and incident recovery, lost opportunities, and productivity. You can ask me about that all day long. I can go ad nauseum the dollars that we spend after a compromise in multiple agencies that I've been in and when I was a consultant in helping organizations recover after a compromise, the dollars that are spent in recovering that organization that could have been saved if software had been built securely from day one before the implementation phase into the environment. A lot of things that you lose that's really not seen immediately is, the productivity side of when you have a compromise, and there's a lot of embarrassment that comes with that. And I can tell you about that firsthand. The other side of it is that insecure software is what I call a pervasive and kinetic threat to critical infrastructure. We talked about how software is in everything that we do. And on the critical infrastructure side, when we're talking about banking, finance, and transportation, we've seen and we've heard and we've talked about globally about how software has been manipulated to wreak havoc on critical infrastructure, whether it's in the United States or whether it's been in other countries, and all because the largely inherent nature of software being very, very insecure. So there is a huge, huge appetite for better software development, secure software, where it's trusting and it's reliable and it has very, very good security attributes. I believe that the prudent approach to having a better computing environment, a better experience, is to have a proactive one. And so software assurance, it has to be a top integration priorities in the enterprise when you're doing a cybersecurity risk management schema. So next slide, please. So our short software is what I call smartware. So, I'm going to, you've heard that here first. I'm going to go ahead and copyright that. But it's a couple of things that I've looked at over the years of working in this industry and trying to understand, in my mind, in my opinion, what makes really, really good software. I believe that it should have superior qualitative and quantitative attributes. That is, it should be secure, meaning that it's free of common vulnerabilities and exposures, and that's what we're here to largely talk about today. I think software should be safe, where any single function does not conflict or impede upon other software functions that could result in severe and deleterious outcomes. Software should also be very, very reliable. Code should be able to be performed repeatedly over and over and over and make those calls that it needs to make and perform functions as expected over extended periods of time without degradation. One of the key things we always look for in software, and sometimes it seems to be the only piece that we look for, is functional. This is what drives a lot of software to market so fast. As long as the functionality is there, an industry, a company can leverage getting software out to market faster, because that's revenues. The quicker you can get out, the quicker you can start generating revenue. But functional basically to me means that the code is efficient and it's designed to only perform a discrete, purposeful set of instructions and functions and no more than that. And then lastly, I strongly believe that software should be extensible, meaning that the code is modular, it has strong reuse characteristics, and it's secure, safe, reliable, and functional. So extensible means that it kind of rolls up all those pieces up to the top. But I want to really focus on the security aspects of that software, and that if we have a forum, an environment, a place like an initiative like S.W.A.M.P, that we can start building assured software, we're well on the path to what I call smartware. So next slide, please. So kind of looking back over time, when I look at by the numbers, this is some of the pain that I felt in some of the organizations that I've worked in the past. And lack of a good software assurance program, it is a very, very painful experience. At some point, software is going to blow up on you, compromise is going to happen, and you're going to have to stand tall and explain what happened, and then deal with the mitigation effects of that. At one time in some organizations I've been in, we tested a number of applications for software vulnerabilities. Like you can see here, out of the 127, 81 of those contain high vulnerabilities that facilitated exposures of sensitive data or system takeover. 45 of those applications, roughly 36%, expose PII, personally identifiable information. And then at another time, in doing some other testing, we tested roughly 50 applications. 41 of those, 82, hosted OWASP, Open Web Application Security Program project. It hosted top 10 defects. 5 of those applications we had to take offline due to high risk. So there goes those lost opportunities, there comes that embarrassment and that sort of thing. Some of the blowback that you get by operating an environment that has very, very poor software assurance capabilities. 19 of those 100 or those 50 applications contain high vulnerabilities that facilitate exposure to sensitive data or system takeovers, and 12 of those applications expose PII. So you can just imagine having to deal with the issues that come out of exposing PII and having to report on that, having to offer up things like credit monitoring. By having a good software assurance program where you're building in security at the front of the software applications, there's a huge cost avoidance that happens on the back end. When all of this takes place, when you have these compromises, there's a lot of costs involved in reconstituting an application. I think a lot of times when we go to a website, we often just think of it as a website and not a system. Think of a website really as just kind of the skin on a car. You have the car looks really good and everything, but underneath it, if you pull the framing of the car off and all the panels and everything, it's really a very, very complex ecosystem that's in there. There's engines and a lot's going on. And the same thing with software in a web application. That presentation layer is just that very pretty, but in the back end, there's a lot of software, a lot of things going on. So to recover that could be a very, very long and costly experience. And that's some of the things that I experienced over the years. And I said, if I had only had a good software assurance program, I could have avoided quite a bit of embarrassment and quite a bit of cost. And in these days, money's very, very tight. So we've got to get more proactive about building in the software assurance activities at the very beginning of the program and the initiative. So we can go to the next slide, please. Some of the assured benefits that we talk about, that Kevin talked about and Dr. Livni talked about as well, is that programs such as S.W.A.M.P, they provide excellent bottom line programmatic benefits. One of the things that happens over time as application development will get faster and faster as your software quality increases. So basically, as you're building in software assurance programs and methodologies, developers learn to code more securely. And I actually stole that from a conversation that I heard that John King did. He's from Military Health Systems a few weeks back, and he's absolutely right. And that's some of the things that I've learned over time, that as developers start to use better and better coding practices as it relates to software assurance, it gets faster and faster to put out software, and the software looks a lot better. Program managers can clearly demonstrate cost avoidance through defect identification or remediation during development and test stages. That's kind of a no-brainer. You see it up front, it's not on the back end where you have to fix it, so your cost goes down as well. And then finally, software built under assurance standards processes streamlined security approvals. So we're talking about accreditation or authorization. If you have basically a standard that you can send your software through, that's a repeatable process that puts out good, secure software, you can readily inherit accreditation and authorization processes right away. You don't have these long delays. Next slide, please. We can go to the next slide, please. So the path forward. S.W.A.M.P. You know, I came here to really be an advocate of the activity. It's absolutely right for providing assurances that software is secure, and that the time to implement software assurance is input at the development stages of the life cycle is now. Patching is passe. And as I said earlier, I'm tired of buying toys that are already broken when I take it out of the box. Given the budget constraints that we're in today, showing value through ROI and cost avoidance will go a very, very long way. And the S.W.A.M.P. provides, some very good mechanisms that can render security posture of the enterprise measurably better. A lot of times we talk about fixing security. Well, I don't really think you can fix it, but I think you can make it measurably better. And an organization like S.W.A.M.P. and this initiative is one of those places that we should look at. And then finally, the community. We've heard this from Kevin. We've heard it from Dr. Livney as well. That the community, all of you out there who's listening, has to be involved. No single tool, process, person, organization can solve this issue. It's going to take a community to render this a better environment. And it seems like it is an intractable problem, but it really isn't. As I like to say, the whole is greater than the sum of its parts. And to that end, we've got to continue to take on this challenge as a community. We've got to pull together as a community and to really support, I believe, the S.W.A.M.P. process to get a better software assurance environment and better capabilities out of software, and demand that software be validated and assured going forward. With that, that's the end of my presentation. That's all the time I have. I want to thank everybody again for having me on this panel, and I'll hand this back over to the moderator. Thank you.
Thank you. Thank you, Jerry. I appreciate your presentation, and actually let's give a round of applause virtually to all of our presenters. It's really essential for today's security executive to have the knowledge and resources to ensure that secure software is being developed within your organizations. Kevin, Myra, and Jerry have certainly brought up some great points today around software assurance and the S.W.A.M.P. process as well, and integrating software assurance within their own internal processes. But I know we have some questions out there, so let's find out about more. We've got several folks have asking, love the Q&A window filling up. So let's go ahead and start with our first question. And we've unmuted all the panelists in order to let you guys decide which one is going to answer the question. The first question is, how does the S.W.A.M.P. protect privacy of assessment runs?
Marone?
Okay, so the way that the plumbing or the things work under the hood is that every assessment run is performed within a private virtual machine, and the input to this virtual machine is being created by the S.W.A.M.P., and then the machine is running isolated from the S.W.A.M.P., and it's generating an output disk that then is being brought back to the S.W.A.M.P. by the S.W.A.M.P. software. So while the machine is running, there's no interaction between the virtual machine and the S.W.A.M.P. This said, we obviously understand that in some cases our users will need to debug or to interact with the machine while it's running, especially when they bring new tools and have to make sure that they are working. And for this, we are going to support what we call an interactive virtual machine that will create a secure session between the machine and the remote user, but not break this isolation between the SWAMP and the machine.
Wonderful. Thank you very much. Our next question is, why isn't S.W.A.M.P included in the comprehensive vision?
Can you repeat that question
Who would
again?
like to take that question on?
Can you repeat that question again?
Certainly. Absolutely. Why isn't S.W.A.M.P included in the comprehensive vision?
You said NIST?
The SAM-8 test
Yes.
set.
NIST?
Oh,
SMATE.
there are. So just so everyone knows, this is Kevin Green.
I know what NIST is, but
Right. This is Kevin. One of the visions I have at the SWAMP is every year I work very closely with Dr. Paul Black from NIST. He runs the S.W.A.M.P project, and one of my visions was to have the SWAMP host the SATE project this year, and we did. So for the first time, the SATE was hosted in the SWAMP. We were able to give out virtual machines to all of the tool developers. So those test cases, the artifacts, the SRDs are hosted in the SWAMP, as well as other community projects such as OWASP, Broken Web Application, WebGo, so forth and so on. So just to answer your question, we have tight integration with the work that is being done at NIST. As I mentioned, we'll be hosting the next SATE project as well in 2015, and I'm looking forward to that.
thank you very much, Kevin. Our next question is function extraction included in the SWAMP tool set?
Who
would like to take that one on?
Is what? I hear extraction of something. Is it
function extraction included in the... Yes, function extraction included in the SWAMP tool set.
At the moment, it is not, because as I pointed out, at the moment we have 5 static analysis tools, but I would like to reiterate that users can bring their own tools to the SWAMP, and we'll be happy to work with users who have tools that they would like to bring them into the SWAMP. And also, if there are specific tools that any of the attendees would like to see in the SWAMP, to get in touch with us, and we'll talk about it, and we'll see whether we can bring them into the SWAMP. So at the moment, for our initial operation, we have been using 5 open source tools.
Thank you very much. Our next question is, what is the SWAMP position on technical debt? And again, that question is, what is the SWAMP position on technical debt?
I'm trying to understand in which dimension of the technical areas that we are dealing with. We would like to help, to support, to engage the community at any level of the technical activities. Now, we are not a research in terms of, don't conduct research, we are enabling research. We have access to experts in the field. For example, our chief scientist, Bart Miller, is also called the father of fuzz testing. So we have capabilities to engage in pretty deep technology discussion. So I'm not sure if I answered the question, but that's my best understanding of it.
Thank you very much. I think you did. I think you did a great job of answering that question. Our next question is on smartware. Do you mean superior qualitative and quantitative attributes?
Hey, this is Jerry. So I did say qualitative and quantitative, but my slide repeats I believe qualitative. So yeah, absolutely, qualitative and quantitative is should be the right language that's on the slides.
Thanks for clarifying that, Jerry. On to our next question, and this is actually again for you, Jerry. Jerry, you've given several good examples of how flawed software is embedded in appliances and vehicles, and these potentially could present safety risks. Does S.W.A.M.P envision tackling embedded software into the future?
This is Jerry. I think that question seems to be pointed at the S.W.A.M.P folks. I believe that I'll hand it over to Kevin or Dr. Livney here in a second, but I did meant to mention at the beginning of the presentation that I don't believe that S.W.A.M.P is looking at embedded software at this time, and this is largely focused, I believe, on open source software and non-proprietary. But I'll have to let the folks at S.W.A.M.P validate that this is not a form yet for embedded software. I'll hand it over.
We have experience with our infrastructure at the level of continuous integration to support specialized hardware in order to run and evaluate embedded software. So if the embedded software can be analyzed on common platforms, then obviously we are ready for that. At the same time, we have the capabilities as we are moving forward to deal with even more heterogeneous set of hardware resources than we have at the moment. And that will be driven by the interest and the push that we get from the community in terms of specific needs. But we are definitely prepared to work in a very heterogeneous environment.
Thank you very much, Myron. Our next question, and I just want to make mention, we might run over a few minutes after the 3 o'clock end time, but we have so many great questions coming in. I want to make sure that everyone gets a chance to have them answered, and if you do need to drop off, I do want to make mention that this is being recorded and will be available for on-demand viewing. We will also have all the slides available as well to be downloaded. So our next question is, how will the S.W.A.M.P be promoted into the larger universe of software developers, and particularly in the commercial space?
Well, this is Kevin.
Does someone want to take that one on?
Yeah, this is Kevin. In terms of our overarching goal and desire for the S.W.A.M.P to be a transitive force in building better software, in satisfying each of those use cases that were outlined today, where the software developer, tool developer, the researcher, as well as the educator and student, being able to, one, leverage the S.W.A.M.P to help us identify improvements and advancement in software. Personally, that information is very important to me because I then can channel that information back to my software assurance program and put research dollars towards closing those gaps that exist in the capabilities of software analysis tools. Another case is it gives tool developers an excellent opportunity to bring their tool into the S.W.A.M.P, calibrate their tool, test and evaluate their tool against a large corpus of software packages. It helps the tool developer identify where the gaps exist in their software, and it gives the tool developer good information on where they need to focus their time and energy to improve not only the tool coverage in terms of the class of weaknesses, but also in languages. How can we improve the tool coverage? But also, we're working with universities as well in bringing the S.W.A.M.P integrating the S.W.A.M.P into curriculum. curriculums. So as universities have software development courses and so forth and so on, the S.W.A.M.P can be the resource that can be leveraged by an instructor, by a professor, to help further reinforce good coding practices and also help as a learning mechanisms to improve software development. So there's quite a few areas where we see the S.W.A.M.P being a major force in across all of those 5 different use cases, if not even more. And also not to mention the supply chain and being able to have the S.W.A.M.P ideally as a way where if I'm an acquirer of software and someone's supplying me software, we can leverage the S.W.A.M.P as a mechanism by which the supplier can check the software into the S.W.A.M.P. The acquirer can then go to the S.W.A.M.P, run analysis on their pieces of software as part of the supply chain, get analysis back, get a risk scoring back, get the mappings, all the mappings to compliance frameworks back, and before he or she acquires the software and bring it into their environment, have a good idea of whether or not the software can be trusted. So, there's quite a different scenarios which I foresee the S.W.A.M.P playing, and those are some of the areas I just mentioned.
And to add on to that question, as follows into the next question that we have, Kevin. The term continuous assurance implies that the S.W.A.M.P can be integrated into a continuous integration development environment, and analysis can be run automatically as part of a build. Is that going to be a planned capability for you guys? And if so, what continuous integration environments will be supported?
Well, I believe we can support that now. I'll let Marone give you a little bit more briefing on the plumbing as it relates to the continuous integration aspect of the S.W.A.M.P.
So the current interface is a web interface, but the design underneath will now allow direct interaction with a software development environment, and we start looking at environment like Eclipse to provide a client software so that a commit will trigger a software assurance assessment and then the delivery of the results. If you look at what we did with Sonotype, we have prototyped this kind of end-to-end capability, because in order to run these 11,000 modules, we had to fetch the modules from their repository, push them into the S.W.A.M.P infrastructure, create the assessment, and then deliver it back to them. Now, we will not have these client libraries ready when we open the door in February, but we are working on them and would be very interested to talk to any one of you who has a specific software development environment that would like to interface it with the S.W.A.M.P as a backend. So we definitely see the S.W.A.M.P acting as a backend to a software development environment.
Thank you very much, Miran. The next question is that what is the relationship between S.W.A.M.P and the continuous diagnostics and mitigation, the CDM, and DHS?
Hello, this is Kevin. So often, the relationship is the fact that the two are two separate projects. One is being sponsored through CSNC, MPPD out of DHS. Our facility is specifically related to testing and evaluating software. While we can provide inputs into CDM, the Continuing Diagnostic and Mitigation Program, that's the effect in terms of which we support the CDM process. We can provide inputs into CDM so that we can provide the continuous monitoring capabilities for application security. So often when we talk about applications, continuous monitoring, I should say, we have done so without bringing the application security context to the table. Now with S.W.A.M.P, we have a way to bring application security context to the continuous monitoring process. So yes, we will be able to provide outputs into a CDM program by providing
Thank you very
the
much.
analysis of results
okay.
and so forth and so on.
Thank you, Kevin. Our next question is, while tools are important, it seems, and we have data to support this, that developers should put the highest quality code into tools such as static analyzers, meaning personal code reviews and team inspections are more important than ever, even in the tools. Can someone comment on that, or what their viewpoints might be? Are you in agreement with that statement, or how would you like to address that?
This is Kevin. I can go first. I think both are very important. I think tools are very important, but one of the issues that we've had with tools themselves have not performed very well, and that goes back to one of my slides when I mentioned that the SWAMP will help create an environment where we can create better performing tools. So we're talking about soundness, we talk about precision, we talk about scalability. And one of the reasons why tool developers typically don't use tools because they don't perform well. They generate a wealth of false positives. It doesn't give you a lot of visibility into false negatives. So I see the leveraging tools as well as the collaboration that happens within the software development environment going hand in hand, and kind of being complementary activities that should be done throughout the various phases of the software development lifecycle, or even as we start talking about something like Agile, where there are specific gates and specific sprints within the Agile development process where these tools can be leveraged that provides more visibility into weaknesses and vulnerabilities before software moves throughout the development lifecycle. Because as we know, the cost to fix a software weakness or bug as it moves through the software development lifecycle significantly increases at each phase.
Yeah, let me quickly add here is that if you look at the track record of our team, we definitely believe in the hybrid approach and understand the strengths and the weaknesses of both sides of this multidimensional problem of software assurance. And Bart Miller, who will will be part of the town hall meeting tomorrow, has been a pioneer in the area of human inspection and also training for software assurance. And I encourage you to attend and to ask him more questions tomorrow when he is on the mic.
Perfect. Thank you very much. I'm going to jump on to our next question. How will S.W.A.M.P test third-party software without source code?
We will not be able, obviously, to apply source code without the source code, source code tools without the source code. So when we'll have binary tools, we'll apply binary tools. We cannot do magic. So
Okay.
And we will also do dynamic. So if we don't have the source, we will use, like I mentioned earlier, the fuzz testing. So we can apply method to software without the source, but we will do our best with what we have.
All right, thank you. On to our next question. What would be the impact if the government requires that contractors provide a guarantee that the code is free of vulnerabilities and OWASP or other defects? I think this is a theoretical question, and they're just looking for an opinion from our panelists.
This is Kevin. I think there would be tremendous impact in terms of being able to leverage a collaborative research facility such as the S.W.A.M.P to vet software, but also have the proper capability in place, when we start talking the federal government, by which integrators who develop software for the federal government can bring the software in and have the software as you know, I heard a lot of people use this term before, to have the software swamped. And what we mean by that is to have the software vetted and identify the critical weaknesses and vulnerabilities, but also being able to articulate those weaknesses and vulnerabilities using a risk management framework so that, you know, it helps expedite the CNA and accreditation activities that organizations have to undertake. So, you know, the SWA.M.P can provide you artifacts to help expedite the certification and accreditation process, as well as any other compliance frameworks that are out there, such as HIPAA, such as PCI. I think having the SWA.M.P in place kind of helps expedite that activity so that people are not doing routines over and over, but kind of can maximize their time in really understanding what the critical weaknesses and vulnerabilities are in software.
Let me add here that, and I think I made a point earlier, that all the tools and the technologies and the software that we develop are all open source. So the core engine that is driving the automation and the execution of the assessment can be replicated, and part of our vision is to make it available. So if every piece of software has to go through continuous assurance, we believe that we will be able to offer not only the capacity and the capabilities within the SWA.M.P, but also the ability to build mini SWA.M.Ps. And a part of our long-term vision is that these SWA.M.Ps can be connected, as I pointed out earlier, that we can move results between SWA.M.P instances to create you know, broader and more comprehensive views, even if the assessment was not performed in a specific SWA.M.P. And I'll be happy to talk to anyone who's interested in it offline on this or any other question. And I really appreciate the diversity and the quality of the questions.
Thank you. And we're on to our last question now. And this is for Jerry. On the 6th slide of the last briefing, at the bottom of your slide, there was a reference to software assurance being a top integration priority. Why is integration highlighted when software assurance applies to all of an SDLC?
Yeah, so in talking about that, it wasn't necessarily a reference to the integration function within the SDLC. I was using integration more in a general sense, and I think the way it should be interpreted is that software assurance needs to be a key point, something that you would have a discussion about when you're building out systems and applications. So the software assurance piece of it today, and in the past, when you sit at the table and systems are being developed, there really was no discussion about software assurance. So simply what I was attempting to say was that in those discussions, we need to make sure that at the very top of that discussion, that software assurance is discussed and it is included as part of the system build out. And again, I wasn't talking about it as integration as one of the phases in SDLC, but merely that it needs to be a top priority in the SDLC, that it needs to be talked about.
Perfect. Thank you for clarifying that, Jerry. This concludes our Swamp Town meeting. I want to thank Kevin, Mirren, and Jerry for their excellent presentations and commentary. As you've all pointed out, insecure software is a real growing problem and it has a lot of areas of opportunity to be fixed. And it sounds like you have a great solution. And we appreciate all of our audience being with us today as well. So thank you so much for coming. I just want to make mention that an on-demand version of today's event with the Q&A session will be offered soon for viewing on demand with you offline or, of course, with any of your colleagues that you'd like to share this with. And again, we will make the slides available as well. So do look for an email announcement with the details on how to access this information. We hope that today's program has been beneficial to you and look forward to you joining us at a future program. Thank you very much, and thank you, presenters. Have a great afternoon.